This shouldn't be happening. The mystery of Comet 29P. Something truly strange is happening in the far reaches of our solar system, beyond the orbit of Jupiter, in the cold frontier where sunlight fades into darkness. A single object refuses to behave the way it should. It explodes again and again. No warning, no rhythm, no obvious reason. Within just a few hours, this object, known as Comet 29P Schwassmann-Wachmann, can become hundreds of times brighter, blasting more than 1 million tons of gas and dust into space, and then fall silent, as if nothing ever happened. And here's the unsettling part. This isn't a comet diving toward the sun. It's not being ripped apart by heat or gravity. It's just out there, calmly orbiting in a nearly perfect circle, far from any source of major energy, yet behaving like the most temperamental volcano in the solar system. Why? What invisible hand keeps pulling its trigger? Is there something deep within this icy world? A buried force? A heartbeat? Something alive in a geological sense that we've completely missed? For decades, astronomers have scratched their heads over this mystery. 29P defies every rule we know about comets. It's unpredictable, relentless, and frighteningly active, second only to Jupiter's moon Io, the most volcanic body in the solar system. So, what's really happening out there? Is this chaos? Or is it a pattern we just don't understand yet? Let me know what you think, because what you're about to see might change how we imagine the frozen worlds beyond Jupiter. Today, we dive into the case of Comet 29P, the celestial enigma that shouldn't even exist. We'll explore its violent eruptions, the strange chemistry that fuels them, and the shocking new discoveries made by the James Webb Space Telescope that are forcing scientists to rewrite what they thought they knew about icy bodies in the solar system. Let's begin the journey. The story of Comet 29P begins nearly a century ago, in 1927, at the Hamburg Observatory in Germany. Astronomers Arnold Schwassmann and Arno Arthur Wachmann were carefully comparing photographic plates of the night sky. And there it was, a faint, slow-moving speck of light, drifting against the background of fixed stars. At first, it seemed ordinary, just another short-period comet, one of many catalogued at the time. But soon, something about its motion caught their attention. This comet wasn't plunging toward the sun in a long, dramatic ellipse. It was staying far out, looping around in a smooth, nearly circular path between Jupiter and Neptune. That orbit was so unusual that it forced scientists to rethink how such an object could exist. Eventually, 29P was reclassified as part of a strange and fascinating group called Centaurs, named after the mythical half-human, half-horse creatures. And that name fits perfectly. Centaurs are hybrids, part asteroid, part comet. They come from the Kuiper Belt, the icy region beyond Neptune, but gravitational nudges from the giant planets occasionally drag them inward, where they live unstable, unpredictable lives. They're cosmic wanderers, caught between worlds, too volatile to be stable asteroids, too cold to be typical comets. A transition, a brief evolutionary stage in this solar system's ongoing story. Most centaurs spend millions of years drifting silently, coated in ice and dust. But 29P broke that mold completely. It's huge, about 60 kilometers across, larger than most of its kind, and it's alive in a way that almost feels defiant. Every year, it erupts around 30 times, releasing colossal clouds of gas and debris. And here's what really puzzles scientists. Roughly 40% of those explosions happen with no trigger, no predictability, and no warning whatsoever. No other known comet behaves like this. It's as if 29P is powered by its own internal weather. A world with a personality, a temper, and secrets buried deep beneath its crust. Think about it. A massive ice-covered body, orbiting quietly beyond Jupiter, exploding in the darkness, again and again. A cosmic volcano that no one fully understands. Why does it act this way? Could this strange Centaur be telling us something about the hidden mechanics of the early solar system? Or, and this is the question that divides scientists, is 29P something entirely different? Something that challenges how we define what a comet even is? What do you think? Is it a comet? A centaur? Or perhaps a glimpse into a process we've never witnessed before? Every outburst of Comet 29P is like witnessing a slow-motion catastrophe written in light. In just 2 or 3 hours, this frozen wanderer can flare up and become hundreds of times brighter, visible even to amateur telescopes back on Earth. But what we're seeing isn't simple reflection. It's an eruption, a massive release of gas and dust, the kind of event that would tear most comets apart. Yet 29P survives, again and again. In 2024, the comet went through one of its most spectacular phases yet. Within just 48 hours, it erupted 4 times in a row, becoming nearly 300 times brighter than normal. Astronomers described it as a fireworks show in slow motion. 2 years earlier, in 2022, it had ejected over 1 million tons of debris into space, material hurled outward at speeds faster than sound. If you could stand nearby, hypothetically, it would be like watching the most pressurized champagne bottle in the universe uncork itself, again and again, in the silence of space. But the real mystery isn't just the violence, it's the pattern behind it. Each major explosion is often followed by 2 smaller ones, roughly 5 to 7 days later. It's almost as if something beneath the surface continues to rumble long after the first blast, like a heartbeat that refuses to stop. The biggest of these events on record happened in September 2021, when 29P unleashed a chain of explosions brighter and longer than anything seen in the previous 40 years. And surprisingly, it wasn't professional scientists who noticed it first. It was amateur astronomers, sky watchers in their backyards, who saw 29P suddenly flare like a beacon against the blackness of space. They were the first to alert the global astronomy community, proving once again that sometimes discovery begins not in billion-dollar observatories, but in human curiosity and a telescope under the stars. And when the professionals finally pointed their instruments toward it, they were too late. By the time the Hubble Space Telescope was ready to observe the comet up close, a sudden technical failure forced it offline. The perfect opportunity was lost. One day too early, or too late. That's how unpredictable 29P is. And here's a question for you. If even our most advanced telescopes can't catch this comet in the act, what else might be happening in the outer solar system? Unseen, undocumented, and beyond our timing. cryovolcanism, the ice volcano theory. So, what exactly causes these outbursts? If your mind immediately jumps to volcanoes, you're on the right track, but not the fiery kind that we know from Earth. 29P isn't burning, it's venting. It's what scientists call a cryovolcanic comet, a frozen world where heat doesn't melt rock, but ice. And instead of lava, it releases something even more exotic. Cryomagma, a mixture of water, ammonia, methane, and nitrogen, all erupting violently into space. Here's how it works. Beneath 29P's outer crust lies a volatile interior, a cocktail of frozen gases like carbon monoxide, and carbon dioxide, CO, trapped within the ice. Over time, sunlight, even the faint sunlight that reaches this far, seeps through the crust, slowly warming the layers beneath. This warmth isn't much, but it's enough to make some of the frozen gases sublimate, turning directly from solid to gas. Pressure starts to build, and eventually, something gives way. The icy surface cracks, and the comet erupts, releasing jets of vapor and microscopic particles of ice and dust that burst outward at incredible speed. The shock wave can lift huge amounts of material, creating a cloud so reflective that the comet suddenly appears far brighter from Earth. It's a magnificent sight and a terrifying one. Each eruption is a reminder that even in the deep freeze of the solar system, volcanic power still exists, but in a frozen form. And here's what makes 29P even stranger: its gravity and size. Most comets are small. When they erupt, the material escapes forever. But 29P is massive enough that much of the debris it throws out doesn't escape its own weak gravity. Instead, it falls back down, settling like snow, slowly reforming the crust that had just been broken apart. It's a self-healing volcano, a cosmic system that tears itself open and then seals itself shut again, ready for the next explosion. That could explain the smaller follow-up eruptions days later, the comet's surface collapsing under, its own new layer of frozen dust, reigniting trapped gases below. But here's where it gets almost poetic. Every time 29P erupts, it reshapes itself. Every explosion is both destruction and rebirth. It's not dying, it's evolving. And that raises a fascinating question for all of us. If even frozen comets can behave like living things, breathing, pulsing, reacting, where do we draw the line between geology and life? The circular orbit problem. Here's where the mystery deepens. Most cryovolcanic comets, the ones that erupt violently, do so for a simple reason. They have elliptical orbits. As they swing close to the sun, they heat up, pressure builds, and the fireworks begin. But Comet 29P? It doesn't follow that rule. Its orbit isn't elliptical at all. It's almost a perfect circle. That means it stays the same distance from the sun all year long, about 6 astronomical units away, in the same frozen region just beyond Jupiter. So, logically, there shouldn't be any sudden changes in heat or radiation to cause explosions. The comet should be calm, predictable, stable. And yet, it acts like a ticking bomb. Why does a world that lives in constant cold behave as if it's boiling from the inside? Why do eruptions occur in random bursts instead of following a neat seasonal rhythm? For decades, scientists have tried to find a hidden pattern in 29P's madness. Some think it's tied to its rotation. Roughly every 57 days, the comet completes one slow spin. Maybe certain volatile patches on its surface periodically face the sun, warming slightly and releasing trapped gas. That could explain some of the outbursts, but not all of them. Others noticed smaller explosions occurring roughly every 30 or 90 days, too irregular to match any known cycle. Could 29P have seasons of its own, invisible ones, driven not by sunlight, but by pressure deep below the surface? Or is something inside it changing layer by layer, like a slow-motion earthquake beneath an icy shell? No matter how advanced our models get, 29P refuses to fit. Its eruptions are chaotic, spontaneous. It's as if the comet is following a rhythm only it understands. And that raises a fascinating question for you watching right now. What if nature itself doesn't care about our definitions of order? What if chaos is simply the kind of order we haven't yet learned to read? A breakthrough prediction. Then, in April 2023, something happened that changed everything. Astronomers monitoring 29P noticed a subtle shift. Its brightness started fading. The gas around it, normally active, seemed to be slowing down. It was as if the comet was holding its breath. Somewhere in that fading light, scientists saw a clue. Maybe, just maybe, the pressure beneath its surface was building up again. And so, for the first time, they tried something bold. They made a prediction. They said, "It's about to erupt." And incredibly, it did. Later that same day, 29P exploded, just as predicted. It wasn't a huge eruption, but it was historic. It was the first time in history that astronomers correctly forecasted an outburst from one of the most unpredictable objects in the solar system. For the first time, we weren't just reacting to chaos. We anticipated it. We didn't chase the comet. We met it halfway. That moment felt like a small victory, not just for science, but for patience itself. Because for decades, 29P had been a symbol of unpredictability, a reminder that even with all our telescopes and data, the universe still dances to its own rhythm. But now, for the first time, it was as if we'd caught the beat. And that brings us to one of the most exciting chapters in modern astronomy, when a new set of eyes looked at 29P and saw something no one had ever seen before. The amorphous ice hypothesis. After Webb's discoveries, one question became impossible to ignore. Why does 29P still contain so much carbon monoxide after billions of years? It should have escaped long ago. To answer that, scientists had to think differently, not about explosions, but about ice. On Earth, when water freezes, it forms crystalline ice, solid, orderly, structured. But in the freezing vacuum beyond Jupiter, water doesn't behave that way. At extremely low temperatures, around 77 Kelvin, minus 196 degrees Celsius, water freezes into something far stranger, amorphous ice. It's disordered, porous, full of tiny pockets where gas molecules can become trapped like prisoners in glass. And when that amorphous ice warms up, even slightly, it begins to reorganize into crystalline form, releasing those trapped gases in violent bursts. If large portions of 29P are still made of amorphous ice, then every patch that begins to crystallize could act like a miniature time bomb. A few degrees of warming, a small rotation, a sunlit crack could trigger an entire eruption. It's as if the comet is haunted by its own past, by ancient gases trapped since the dawn of the solar system, still trying to escape after millions of years. Now imagine this. Smaller Centaurs, little icy worlds only a few kilometers across, have already gone through this transformation. Their amorphous ice is gone, converted into stable crystal long ago. That's why they're quiet, predictable, dead. But 29P, it's enormous, about 60 kilometers wide. For a world that large, it could take 60 to 100 million years to fully crystallize. That means that, right now, it's only halfway there. Half of its interior is still amorphous, still unstable. A ticking geological engine buried beneath ice. Each time a region transforms, gases explode outward, cracking the crust, hurling debris into space, reshaping the surface. And when that debris falls back down, sealing the fractures, the process starts again. Explosion, collapse, rebirth. Over and over, a frozen cycle of transformation that has lasted longer than human civilization itself. So maybe 29P isn't just a chaotic comet after all. Maybe it's a messenger, showing us what happens when ancient matter still carries the memory of creation. And here's a thought for you. If this is how a comet behaves when half of it is still transforming, what will happen when the other half finally catches up? A matter of scale. In science, size changes everything. From the tiniest dust grain to the grandest planet, the rules stay the same, but their effects grow monumental with scale. For smaller centaurs, the story is simple. They heat up, crystallize, and fade into silence. No surprises. No drama. Just cold, predictable sleep. But Comet 29P? It's a giant among them. 60 kilometers across, layered with billions of tons of frozen gas, dust, and volatile ices. That size gives it something rare, the ability to hold on to its own chaos. A small comet vents and dies. A large one vents, collapses, and starts again. Researchers modeled what happens inside objects like this. The results were shocking. Even after tens of millions of years in the same orbit, only half of 29P's ice has completed the transition from amorphous to crystalline form. The rest still holds ancient gas, compressed beneath frozen layers thicker than mountains. When one patch converts, gases burst free and fracture the crust. Then gravity drags the fragments back down, sealing the wound. The pressure builds again, and the next eruption begins. A constant cycle of destruction and renewal. If you could speed up time and watch from above, you'd see a world endlessly rebuilding itself, breathing, exhaling, refreezing. It's not just an object anymore. It's a process, a system. And maybe that's what fascinates us most about 29P. It's not only strange, it's alive in motion, a frozen echo of creation that refuses to settle. So here's a question for you. If a comet can rebuild itself endlessly, could it one day evolve into something new? A different kind of world entirely? The chaotic heart of 29P. Deep inside this icy wanderer lies a landscape we can only imagine. Caves carved by sublimating gas, tunnels collapsing under their own weight, vast chambers filled with invisible vapor. Some astronomers suspect that these internal collapses, not just gas release, may be the true engine of 29P's behavior. Each time a chamber caves in, pressure surges through the comet's interior, igniting new vents on the surface. From the outside, we see only light, brief flashes, bright arcs of dust. But inside, an entire planetesimal is shifting, cracking, changing shape. And that raises another puzzle. Even if crystallization explains the gas, how does pressure rebuild so fast? How can something so distant from the Sun explode multiple times a year with such force? No model fits perfectly. 29P bends every theory we throw at it. Maybe we're missing a piece, an unseen rhythm inside the comet, a pattern too long or subtle for us to measure. Some scientists half-jokingly call it the heartbeat hypothesis, the idea that frozen worlds might pulse as they expand, freeze, and contract. It's poetic, but perhaps not entirely wrong. Imagine a heartbeat you can't hear, measured not in seconds, but in decades. Each pulse releasing gases born at the dawn of the solar system. It shouldn't happen, and yet it does. Maybe 29P is showing us that even silence has rhythm, that even chaos can follow a beat. So, what's really inside that chaotic heart? A geological engine? A buried fracture system? Or something even stranger? A relic still alive with the energy of creation? Tell me what you think in the comments, because out there, beyond Jupiter's orbit, something is still moving, breathing, and breaking the rules.